The abundance of water forecasts whether life on Earth is thriving or declining. At the core, water is an indispensable resource enabling all planetary ecosystems to function and prosper on Earth. Consequently, any pressure on global water resources will in turn impact both natural environments and human livelihoods. Amid the escalation of human-induced activities since the 18th century, water-related challenges have been significantly increasing. Today, over 2 billion people live in countries experiencing high water stress, 780 million lack access to clean drinkable water, 2.5 billion people do not have access to safe sanitation systems, and 2 to 5 million people, mainly children, die as a result of preventable water-related diseases every year. As a result of water insufficiency and government mismanagement, several countries experience concerns of water scarcity. Here, we address urban water challenges through using a systems thinking model to review shortcomings of water security and availability, as well as the implications of water scarcity. The model illustrates the interactions and relationships that consumption patterns, demographic changes, and impacts of climate change have regarding water insecurity and scarcity. The source in this figure is water security and availability and generally stable conditions within the water sector. Amid changes in demographic and consumption patterns, the flows in include population growth, consumption patterns, increased water usage, increasing demand for agricultural and energy production, pollutants and contaminants in water systems, and a lack of education. These flows in contribute to the stock, which we've chosen as water shortages, where availability does not meet its demands. The flows out that get us from water shortages to ultimate water insecurity and scarcity are all climate change impacts and global dynamics. These include freshwater variability, industrial and commercial activities, extreme weather events such as floods and droughts, rural-urban migration, changes in energy and commodity prices, changes in global market, land use change, increasing water demand, waste management, and challenges in water affordability. All these factors result in water insecurity and scarcity, which is labeled as the sink of the model. This model has 4 balancing and reinforcing loops. The first one is the balancing loop, which connects water shortages back to water security and availability. This balancing loop is titled Urban Water Research and Technology. Here we suggest that with the aid of universities, NGOs, think tanks, research centers, industry bodies, and international organizations through urban water research and technology, water shortages can be in fact reversed and brought back to global water security and availability. The second balancing loop is the interaction between the sink and the source, where water communities suggest that to manage urban runoff, provide protection from floods, and develop low-impact infrastructure in urban settings, there's a need of collaborative actions such as green nature-based structures, grey infrastructure, and finally blue spaces such as green walls, roof gardens, and vegetation infiltration. This loop helps balance the system and bring water states back to being secure. The last balancing loop cycles between the sink, the institutional and governance influence, and the flows out. Here we see that as climate change impacts and global dynamics worsen, they cause water insecurity and scarcity, which in turn calls for institutional and governance aid such as management, finance, policies, data, and accountability. In addition, these bodies facilitate initiatives like the right to access to water, funding the public health sector, educating the public in need, making water affordable to all, and prioritizing people suffering from poverty. All these factors contribute to addressing water insecurity and ensuring water reassurance. The first reinforcing loop is between the sink, stock, and the implications of water scarcity. Here we illustrate that as the state of water shortages worsens, it leads to water scarcity, which then has further implications. The implications of water scarcity include the appearance of water-related illnesses and diseases, food insecurity, sanitation problems, demographic changes due to dehydration, thus population decline, biodiversity loss due to desertification and dehydration, potential extinction of wildlife and humans, green spaces drying up and no longer being a cultural aesthetic ecosystem service, hydropolitical problems, and finally potential water wars. To conclude, water security emphasizes the notion of limits to growth as it highlights how finite and increasingly scarce fresh water is. Therefore, systems thinking is a key tool for understanding the web of interrelations that create these water challenges. This model emphasizes potential to empower water managers, urban planners, policymakers, and other stakeholders to address the root causes of urban water challenges.